So our agenda today, we're going to do an overview of Solid Edge and the CamPro interface. We're going to do a description of the file structure and how it relates and talks between the two softwares. We're going to discuss the associativity factors between those softwares and how we are linking our CamPro program to our Solid Edge part file. Then I'll do an introduction to CamPro where we'll focus on the 2.5D milling package. The reason why we're focusing on the 2.5D milling package is because out with every Solid Edge Classic or Premium license, you have the ability to get a new license file generated that has the CamPro 2.5 axis free of charge. So this is available to you with no additional add-ons to you. Now, if you have current software that you're above the 2.5 axis level to where you're doing 3 axis or 5 axis or turning, you can always add to this software. It's modular. So out of the box with your Solid Edge license, you're going to be able to do 2.5 axis CamPro. So that's why I'm focusing on that. And with that package, you're also going to do what we call feature-based manufacturing and automation. And what that is the ability to have CamPro recognize features from Solid Edge. And then we can have standard machining practices and machining tooling sets that we can automatically program the parts using feature-based manufacturing. And I'm going to show a demonstration of that. Then I'm going to be showing an engineering change order. And with your current software, third-party softwares, you may be seeing a lot of frustration with how do you recover from an engineering change order. If you have an engineering change order in third-party softwares, the majority of the time you're creating new program, copying operations to the new program, and then opening those operations and reselecting geometries. With CamPro for Solid Edge, we don't have to do that. We simply have our revision, open it in CamPro, save it so that it's a CamPro file, and then use our replace component command, and all of the operations will automatically reassociate to the geometry and automatically update. And I'm going to show a recovery with a revision 2 part. So here's the Solid Edge CamPro interface. So on the left-hand side, you see I have the bracket that I'm going to be showing you, the assembly file. And the right-hand side is the open splash screen for the CamPro software. So with this slide, we're going to discuss the file structure. So you can see that in the left screen, in the red box, you see that it has an underscore PAR, and that's the Solid Edge suffix, the file extension. So what's happening behind the scenes is when you open that up, it's saving out a copy of that file, but as a PRT file, which is a CamPro file. There's a link that's established, so it's always looking back to that Solid Edge file, so that if the Solid Edge file differs, it will register against the part file, and then it will show the outdated status in your CamPro file, signifying you that you need to do an update. So that's the background file structure on how we communicate back and forth using what we call the master model concept. The Solid Edge file drives all of the associativity downstream. If it changes, then we use our replace component command to replace the component and then run our update. So now let's talk about the 2.5 axis milling demo. So inside of Solid Edge, I'm going to go ahead and open up that file. This is asking me to open the entire assembly. I say yes. So now that this is open, we have a link here that's in our quick access bar, or we also have a link in our tools environments. So we're going to choose this one. It's going to route to the CamPro software. Whatever is on screen now is becoming our master file. So it's taking that, opening it in CamPro environment, ready for us to start programming. Since this is an assembly, we have to go a step further, single out what part we're actually going to start machining. This is going to be that 60mm pulley. So I'm going to right click, open a new window to single this part out. Now we're going to go and utilize the templating within the Solid Edge CamPro product. And what this does is this gets us going very quickly in the environment that we're stating here. So a general setup is going to give us, as the bitmap shows, all our machining practices. If we were to choose turning, you're going to see now we've singled out just our turning operations in our turning environment. Multi-axis or mill turn, it will single out and it will construct our file in the manner of what we need it for this type of application. So for this example, I'm going to choose general. General, as I said, gives us all of our options. Now with our file structure, you can see that my original part file name is the prefix with a suffix of setup_1. This just lets us know that this is the CAD file that drove this manufacturing file. So now we have to set the file up correctly. So we need to set our 0 location. It'll be oriented in this manner. So I would want to select this diameter. It'll snap it in center. I'll choose this leg, this vector on this surface. It'll snap that normal to. And then I'll take my Y vector normal to this wall. So now that I have my 0 location established, I have to set my workpiece. I have to let CamPro understand what is the finished part that I'm machining. Now, I'm telling it what is my blank material. And for this, I'm going to choose the automatic option of bounding cylinder. I'll tell it that it has a small amount on top with none on the bottom, which would leave 1 millimeter on the top of the surface. Now, this is an automatic function, so it's populated that in my part navigator. I'm going to go ahead and hide that. So the reason why it's so important to have the blank and the part is because NX is volumetric in nature. Unlike other softwares where you're specifically telling it what geometry to cut, where to start, where to end, CamPro is looking at this part volumetrically what it's doing is it's looking at the finished part comparative to the rough material, and then it will create tool path accordingly and efficiently so that there's no air passes. CamPro has a utility in the background running at all times called in-process workpiece. Every time the tool has taken a volume of material away, the next and subsequent operations utilize that in-process workpiece to drive the tool path downstream. So that's why it creates no air passes. So now that I have this, I can go ahead and start programming. So we'll target these pockets. At this moment, I don't know what these radiuses are, so I need to know what they are for tool selection. Radius of 3, so I can choose a 6 millimeter tool. So I'll come here, create a tool, an end mill, putting it in pocket 1 of the machine tool, and we'll call this 4 millimeter. 4 millimeter. I can also come to the library, which CamPro has a vast library of tools already in it for you to select from. I'll grab a holder. We can preview this, be like a collet. Now we'll come back to this tool and make it more realistic. It's definitely not 50 millimeters worth of fluid. It's more like 20. It could be 75 millimeter long, but 50 of that's going to be in the holder. So now we have more of a correct tool. So now I'll create geometry and I'll tell it that I have some mill areas. What this does is I'm just going to select geometries for it to cut so that I can reference them and not have to pick them later at a later time. For instance, if I had 5 tools that went in this pocket to create the geometry, then if I did not create this geometry, then all 5 operations, I would have to go in and select all these surfaces each time. In an effort to go quickly and more efficiently, we're just going to go ahead and select these and create something that we can then in turn reference at a later time. So now I'll create this operation. For this operation, I'm going to go ahead and choose pocketing. Let's choose floor without wall. We'll choose a tool, the mill area that I just created, and we'll say we're going to rough this. So now by doing that, the wall geometry, we're going to start inheriting information from the higher levels. So the geometry now is the mill area. So now I don't have to come through here and select that geometry because it understands what it needs to cut. So we also have this prediction section here where it's going to try to figure out what it needs to do by your past history. So there's AI running in the background that's trying to help you through your past selections and what you're currently in to find the best machining solution. So now this operation is asking for our walls. So we'll come through here. We'll have quick settings. We'll select the wall. We're telling it that we want to use that in-process workpiece that I just talked about. And we want to tell it that we want, not there, we would like a 2 millimeter depth of cut. Now we will get our toolpath. We can verify, show 3-dimensional material removal. So that's creating just a wall pass. So if we did percent of flat diameter, we could do this as 10%. Now that'll give us the ability to have more infill passes. Now we also have other operations that we can choose that are more of a planar style roughing strategy. So let's go ahead and utilize this toolpath. Now this is asking us for a little bit different information. What are we cutting? We can say faces and say that we're cutting a face. If we had a face geometry that we could have, we could say that we want curves. So for this, I'm going to say I want a tangent curve, pick a different pocket, tell it that the tool is on the inside, automatic plane, and then it's going to ask us for a floor. What is our end volume? We can generate. Now we can also tell it that we would like 2 millimeter depth of cuts. And we have this auto predict on, auto generate. So you see every time I update, it's updating the operation as I go. So very quick and efficient. So it's a very simple tool to use, and it's very powerful. The output that you get is very powerful. So now let's look at how NX handles holes. So let me back up. So let's look at that. So you saw how this is a planar operation. It's relying on geometry to cut. Now let's look at an operation that relies volumetric. So if I come through here and I choose a cavity milling operation with the same tool, I don't have to specify anything. CamPro will say, I will take the volume of the blank compared to the volume of the finish, and it will give me toolpath accordingly. So it's a very intelligent style toolpath. So you see how it's recutting this pocket? It's because I do not have that in-process workpiece turned on. You saw a toolpath created there. So now if I use the 3D IPW, you'll see that the toolpath is restricted in that area because it does not see material. So it's very highly intelligent. So let me remove these. And I'm going to show you another toolpath that is our high-speed machining strategy. This also looks volumetrically. So if I choose not to put any cut definitions in, it's going to do the entire part. Let me show you that. If I do go in there, let me go ahead and show you what this is. This is meant for long axial, very shallow radial cutting strategies. Very light machining, but very fast volume material removal. So you'll see that it navigates between many different cut strategies. It's not one strategy along the entire toolpath. And it's a very efficient type of toolpath. Now you see how it did everything because I didn't select any type of cut pattern or cut area. So if I wanted to do that, this particular operation, you just use these trim boundaries and you would do much like the previous operation I showed you. You would tell it what you would like to cut, what side of the area is trimmed, where to start the cutting from, and then what my ending point is. And it gives me the toolpath. So that is our very high-speed material removal. Now, this is in a roughing strategy. So if it has material left over, mill rough, and it has 1 millimeter. So now one of our next operations that we could use would be our patented rest milling. This is to go directly after roughing strategies to cut the rest of the material. So if I just went ahead and left that tool alone and selected finish, you'll see that this operation is only going to cut material. It's not going to look at that as volumetric. There was material left on it, and these also had material left in the pockets. So you'll see that intelligently cut everything where there was material only. Very important that you see the differentiating factor between only where material is located. So that pocket was already cut out, 1 millimeter left on it. So you'll see how the toolpath will start to shift around that 1 millimeter in that pocket that's been removed. And it navigates all the material left in. You see how it's cutting just material left. It's a very intelligent pattern of toolpath to accurately cut your part. So now we will go into hole making, because hole making is much different than other softwares. The CamPro software is also volumetric when it looks at the holes. It is looking at these features as an entire feature and not just a point that you're telling it to put a specific tool in. So a couple caveats to hole making. You never have to specify a center line. If you're doing 3+2 machining and this were to be on the side of the part, the tool is always going to go center line of tool, center line of feature, and the post processor is going to work out the rotations. So it's very intuitive when it comes to how it looks at holes, how it rotates things around for multi-axis machining, whether that be 3+2 or full 5, and how it outputs. So just so you're aware at this time, I'll let you know that the 2.5 axis module is fully capable of doing 2 plus 2.5. So you could put 2 rotational axis. If you had a 5-axis machine, you could use your current solid edge package with 2.5 axis milling and do rotations. You wouldn't be able to do contoured rotations as far as tool in motion like surface machining, but you would be able to position 2 axis in a position and then do a drill or a 2.5 axis mill. So you are capable on those types of machines. The post processor handles that, not the software. When you get into axis in motion while cutting, that's when you have to have full 5-axis software, which is an upgrade. So now let's look at this. So I'm going to go ahead and create another geometry like I did before, except this time I'm going to, in the drop down, choose hole making. I'll choose hole making. We would generally name what this is. And then I'll go ahead and select this hole. Now all the attributes of this hole are now pulled into this dialog. You see that it's found the orientation, it's found a data, and the location, the direction in which it's going to be machined. Now it's listed here. If I go create operation, I need to find out what diameter that is. So I'll use the analysis tool again. 1.45. So I'll have to get a drill that's 1.45. So we'll go ahead and create an operation, and I'll choose drilling. No tool. I'll choose that geometry that has this hole in it, and a drill method group. Now I have no tool, so it's telling me that no tool is defined for the operation. But now if I start cycling through tools, I'll retrieve a tool from the library. And the closest that we have, I believe, is 1.5. So I'll select that and then alter. Here's 1.5. So now I'll edit this. But do you see how with me choosing a 1.5 drill, I get an issue here. It says tool diameter is greater than the featured diameter. The tool will gouge the part. So CamPro is looking at this and it's saying I can't do this. So it's a very intelligent and intuitive hole making strategy in regards to our software, as opposed to other softwares that are point machining. You're just giving it a strategy at a point location, and there's no real interaction with the model to say whether it's good or not. CamPro, we have that capability. So now when we come in and edit this, change it to 145, you'll see that arrow goes away, that error message, and we get a clean toolpath. Go verify. I'll reset that and take it slower. So that's a very simple way of going about it. Now, if we want to do the center hole, we would do the same thing. Let's find out what's the size. 6 millimeter diameter. So then we create operation. This time I'm just going to not have a work group to choose from, and show you what you would have to do each time if you chose not to create geometry groups. You'd have to specify the feature in every single operation. So now we're going to grab a tool, 6mm. And what you do is you would grab these out of the library, adjust them, and then send them back to the library. And you see how this magenta circle changes? Now, if I were to change that tool to say the 4mm, that's the end mill that's already in there, you'll see that my magenta volume changes because it's looking at the in-process workpiece of what that particular tool can do. So now with the correct tool, the whole feature, and we click OK. So now, say that I've showed you this and how I've showed you how CamPro works with the standard programming. That's creating your tools, creating your geometries, and creating your operations. Now let me show you a brief slide on automation and feature-based manufacturing. This is where you're asking CamPro to look at predefined features that it can recognize out of Solid Edge, going to the out-of-the-box machining knowledge database to find tooling and operations that suit the geometry. Out of the box, you currently have the capability to run this mechanism, but the goal would be, because it's not going to come out exactly how you want to machine it, so you would alter it and then teach it back to the system, so the next time it does it the exact same way you would like it to. To be able to teach it back to the system, you need another piece of software called feature-based manufacturing authoring. But to be out of the box, you have the ability to utilize this mechanism. And then we'll show the engineering change order. And that engineering change order will be larger pockets, and that hole will be moved. So let's move back into CamPro. Okay, so now I'm going to go ahead and I'm just going to erase these and start from scratch. The only thing that you need to have this mechanism work is you have to tell it what my part is and what my blank is. Now I'll come here to the feature navigator, and I'm going to ask CamPro to find the features from this predefined list. You can see at the bottom it's finding them, and now you see it's found all these different types of features from the CamPro product. We're going to go ahead and click OK. Now if I expand this is going to show me those features. I'm going to highlight them, and it's even intelligent enough to know that I cannot cut this square corner groove with a rotating tool, so it's assuming it's a wire EDM feature. So I'm going to right click and I'm going to create feature process. These are the out-of-the-box feature types and operation types. Now this is going to give me, this is nothing altered, so this is going to not give me the correct program, but I want to just show you the intelligence. I'll expand, and then I'll generate and see what the software gave me with no help from me. Imagine if it had help from knowledge, our libraries, everything that we have. Now I'll go ahead and verify. So you already have to program it once, correct? So what if right directly after you program it, you just go and teach operation set, teach it to the system, so the very next time it finds this type of slot, it uses that logic. So it's a very sophisticated tool that's easy to use, easy to program, that gathers your historical data so that you know that you can have proven processes at play. This, as I said, was out of the box. Now, say we would like this to be a little different. All we would do is create the operations, do it the way we would like to do it, and then right-click, Object, Teach Operation Sets, and this is the conversational dialog box for everything that has to do with that operation and how it's supposed to function. We can just create the rule, and every time it finds that exact situation, it will do this logic. We can even go further and alter these parametrically to say not just this thickness, not just this width, but a range of thicknesses and widths that tool set will work for. That way, if the feature moves width or length or height, then it will encompass the same tool set and operation set. So it's very sophisticated. So that was an extremely great demonstration of just what you can do with the power of out-of-the-box NX. And then by tweaking it just a little bit, you can have an extremely powerful tool, not only for programming, but you could then take this up front to quoting, and they could produce a 95% accurate quote within minutes without bothering the manufacturing group or the standard quoting processes. So it's very powerful, and it has applications in a lot of different places. Okay, so now I've showed you the feature-based manufacturing and the automation. Now let's go to the engineering change order. So with your current software and what you're probably familiar with other softwares is, if at this moment I send this out to the floor and they make it, I come in tomorrow and they say, I have a revision to this part, we need to update the file. Your current process would be create another file, with your new revision, copy these operations into your new, open them up, select the new geometry, and reprocess. It's a long, arduous process. What we do it with CamPro is we would just go into, if our Solid Edge had a new revision, then we would do the same thing, route it to CamPro. Then we would simply just save it. That would save the part file that's associated with that new revision. Then in the assembly navigator, we right-click, replace component, browse out to that part file that's associated with your revision. And then this will place it directly over top of it in on location. You'll see that my toolpath now has out-of-date symbols. I simply just regenerate. Everything is associative with Solid Edge to CamPro. So it's a very, very strong software. You have an extremely large amount of power in the background, and it is a very intuitive software to use. And remember, this is free to use if you have a current Solid Edge license. You may just need to request from us to get an updated license file. Then you will need to download the CamPro software from the Siemens support page that's associated with your Solid Edge version, and then install it as per instructions, and you'll be able to utilize the link within Solid Edge. And also remember that as a customer of Saratech, you have 6 hours worth of free mentoring each maintenance year that you can apply to learning some things to do with the CamPro software to get you going or help getting it installed and implemented. So here's some notable takeaways. Solid Edge CamPro is seamlessly integrated together, fully associative, and intelligent automation to control the downstream process. You can easily recover from an ECO with minimal time or effort from the user. So it's an extremely powerful tool paired with Solid Edge. You can also, as I said, modular. You can build this up to add other modules to include your CMM, to do other items within the CamPro software. And you can also add higher level functionality as far as 3-axis, 5-axis, feature-based manufacturing, authoring, simulation. All of our modules are a la carte per se. You can add them with add-ons.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.